Good day, students. Today we are considering a topic titled electrical field, and it's talking about electrical force between 2 point charges, which is Coulomb law. In the year 1736 to 1806, Charles Coulomb investigated the nature and the magnitude of the electrical force between point charges, and he came about with a theory that if two bodies were small compared with the distance between them, the electrical force is inversely proportional to the square of the distance between them, and directly proportional to the product of the charges, which is synonymous to the work of Sir Isaac Newton under gravitational force, which shows the relationship. Isaac Newton shows the relationship between the gravitational force, the masses, and also the distance between the masses. Sir Isaac Newton said the gravitational force is directly proportional to the product of the masses and inversely proportional to the square or the distance between them. Now, when we see and analyze it, we notice that Sir Isaac Newton came about the law of universal gravitation, okay, and which deal with the product of the masses and inversely proportional to the square of the distance between them. But Charles Coulomb in 1736 to 1806 based his own on the charges, which say that electrical force is equal to the product of the charges, and inversely electrical force is directly proportional to the product of the charges and inversely proportional to the square or the distance between them when the charges are small compared to each other. Now let's see. And it talks about the inverse square law, the way Sir Isaac Newton talked about inverse square law. Okay, now there is also an electrical force between 2 point charges. The French physicist Charles Coulomb, 1736 to 1806, investigated the nature and magnitude of this force. He showed that if the bodies were small compared with the distance between them, then the force between two such bodies was inversely proportional to the square of the distance r between them. Hence, F is inversely proportional to the square of r, the distance between the charges. This is an inverse square law. Okay, this is an inverse square law. Coulomb's investigation showed that the force was also proportional to the product of the charges Q1, Q2 on the two bodies. You can see now a combination of the above expression, this the inverse square law, and the product of the charges resulted to Coulomb's law, which stated that the electrical force between 2 point charges Q1 and Q2 separated by distance r is directly proportional to the product of the charges and inversely proportional to the square of the distance between the charges. You can see F is directly proportional to the product of the charges Q1, Q2, and inversely proportional to the square of the distance between them. F, when you remove the proportionality constant, you introduce K. K equals constant of proportionality. F is in Newton. Q1, Q2 are in Coulomb. R is in meters. K equals 1/4 pi E naught. Is a constant and it has value. Okay, look at the value. K equals 1/4 pi E naught equals 9 times 10 to the power 9 Newton meter square per Coulomb square, where E naught is a constant known as permittivity of free space. Okay, F equals 1/4 pi E naught times Q1, Q2 over R squared. It gives the magnitude of the force that either object exerts on the other. You can see the unit of E naught is Coulomb squared per Newton per meter squared. Okay, now you can see direction of force on charges. When they have the same sign, they repel. That is, like charges repel, unlike charges attract. Positive, negative, they attract. Okay, now let's see how. Let me show you how we got the unit of E naught to be Coulomb square per Newton per meter square. You can see that this is our E naught here. You cross multiply. For E naught, let's see. We want to get expression for that. Expression for the unit of E naught, permittivity of free space. Let's see. You can see you have F equals Q1 Q2 over this is a constant 4 pi, so that's value E naught R squared. You cross multiply. When you cross multiply, you have Q1 Q2 equals 4 pi E naught F R squared. We are looking for E naught. Divide both sides by this is a constant. You can leave this constant 4 pi, it has value. Divide both sides by, okay, let's just write it 4 pi F R squared. 4 pi F R squared. This one cancel this one cancel the. You are left with E naught equals Q1 Q2 over 4 pi F R squared. Okay, Coulomb times Coulomb is Coulomb times Coulomb over, this is a constant, force is in Newton, this distance meters squared, which this one will now be E naught equals Coulomb squared. This one will go up per Newton, turn it to negative, is okay, and this one minus 2 m minus 2. This one minus, that's how we come about this unit for the permittivity of free space. Now let's see how we got the unit of this unit of constant expression for unit of the constant K. You can see this is a constant K. You can have F equals K Q1 Q2 over R squared. Cross multiply. You have K Q1 Q2 equals F R squared. Divide both sides by Q1 Q2 Q1 Q2. Cancel each other. You are left with K equals force is in Newton. Okay, this R is meter squared, distance, over Coulomb times Coulomb equals Newton meter squared over Coulomb squared. K equals the constant Newton meter squared per Coulomb squared. It will be negative when you are taking it up. Okay, that's how we got the unit for the constant Newton meter squared per Coulomb squared. The next class we are going to deal with calculation under electric field. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.